You will be there. Yes. Yes. Okay, let's go. Let's think now. All of the possible here. Yes, there are many empty spaces right now, so fill them up. Let's have some space. Well, at the same time, don't forget to subscribe to our channel. Yeah. And subscribe to the channel of Gamecan. Today we have two speakers from Gamecan. They are leading right now Estonia into the Unreal Engine world. And they just finished the course of Unreal Engine. How many months was the course? 3 months. 3 months course of Unreal Engine, and their students are here with us. They came from Pärnu, especially for this meeting, and I'm very happy because I haven't seen you guys for a long time, I would say. And yeah.
Global Game.
What?
It was in Global Game.
Ah, yeah, yeah. Gamedev. Yes, we met on the Gamedev event.
Okay.
Some of us, I think, yeah, we met on the Gamedev event. Yeah. See, it's getting better and better and better. Again, I'm very sorry for a small space for such a big crowd, but at least, you know, the view is very beautiful. And the drinks are good. Yeah. And the personal is great. Yeah, yeah. The best, the best. So, now, let's listen to the next presentation. And after that, I think we will quickly do the second presentation. We'll make them together. And after that, it will be a total party. And yeah, and rave, as usual, rave and yeah.
Hello guys. Unfortunately, before I came here, I broke my glasses. So I had to visit to bring something. So sorry. I got a little bit headache as well. So I can't eat with one hand. Okay. Our talk is going to be about the some features of Unreal Engine that I'm using as a game designer. So it came from my experience with that tools. That is my personal point of view of that. Maybe all of you guys already familiar with that tools, but I'm going to explain this kind of stuff that would be good for game designer and level designer stuff that want to work with Unreal Engine as a content creator. So, first of all, I'm a technical game designer at Gamecan. So I'm a former Unity programmer, but I'm working as a game designer for more than 4 years, but I have experience in game industry for more than 8 years as a producer, programmer, and game designer. And recently I got my Unreal Engine authorized instructor badge, and I'm teaching as a Unreal Engine instructor in Food Cycle Academy in Pärnu.
Try this. This one goes. Okay.
So the first thing that is so important for us as a game designer is rapid prototyping. You know, most of the product that we are using every day is the result of endless design, prototype, iteration, failures, and so in rapid prototyping we should embrace experimentation. And in rapid prototyping, we should take care about something like a fast iteration, definitely we should design first, prototype, playtest, then design, prototype, playtest. So it's a iteration. You know that the game design is a iterative process. So it's not just a single design, it's gonna be finished and done. And so the rapid prototyping is gonna be for proof of concept as well, and confirm or reject some game design hypothesis stuff. So you should design something that comes in your mind. Yes, and make a fast prototype, test it. If it needs, keep it. If not, throw it out. Go for the next iteration. So it's gonna be so fast. Then one of the first things that helped me a lot in fast iteration, fast prototyping is templates. You know, for every type of the game, you could find a template to go and after it and make your stuff in the template. So it's gonna help you to make it faster. And Unreal Engine already made some template for you guys. So it's gonna cover everything like first-person shooter, third-person, top-down, maybe a strategy, maybe RPG, a racing game, VR, or other stuff. And recently I saw that there is a simulation stuff and some other template. And if you couldn't find your template from the predefined stuff in Unreal Engine, you can download from the marketplace. There are a lot of free stuff that you can get it as a start point. So, the first thing that helped us in rapid prototyping, fast iteration, is visual scripting. You know, all you guys already familiar with visual scripting, but visual scripting is kind of script that you can work with some visual stuff, some visual element to define some logics for your game. So it's not only locked with the game development. In all other science, there are some visual tools to make your logic. And in Unreal Engine, the main feature of the Unreal Engine is the blueprint visual scripting tool, and that would be good to support traveling with. So, Blueprint is a great tools for me. Was great tools for me, and is a kind of empowered designer to make a prototype, to interact, make an interaction, make a gameplay mechanics with it. So is kind of the first things that Unreal Engine encouraged me to use it. You know, I was a Unity programmer when I joined work at the game designer. When I saw the visual scripting, the blueprint, wow, encouraged me to, okay, that's cool. I can make a lot of things with the blueprint. Okay, let's start. So as I started working with Unreal Engine since 2018, the first thing that encouraged me was blueprint. And you can see a simple example of a blueprint. The image. So, with visual scripting in Unreal Engine, you can do a lot of things. You can make a lot of contents. The first thing is UMG, Unreal Motion Graphics, is the UI mockup tools that you can make a lot of UI stuff like Adobe XD, like Figma and other UI tools, but it's so easy. And if you learn visual scripting, it's the only tools that you can use just to make faster and bring to life your user interface. I know that in Unreal Engine there is a programming part for user interface. We call it a slate. It's a little bit weird for me. It's hard to learn it. It's got the structure is a little bit weird for me compared to normal programming. But the UMG stuff is so easy to work with, and so the first thing that I learned how to use the blueprint, it was UMG. So blueprint is not only the tool that you can make your game. Maybe you can make your stuff after the the base classes that made by programmer in CPP, and you can put your functionality on top of the base classes with visual scripting. And with visual scripting in Unreal Engine, you can make your animation stuff. There are the tools for animation. We call it animation blueprint. You can make your state machine of the animation. You can make event graph that get a lot of stuff from the character, from the gameplay stuff, and connect it to the state machine and bring your animation to life. So is the other part of the Unreal Engine that lets you use the visual scripting. When I say visual scripting, is not only blueprint. You can use visual scripting most of the content creation tools in Unreal Engine. The next thing is material creation. In the material creation, you can use the visual scripting as well, and can make shaders, master material, a lot of stuff with that. And we have behavior tree in Unreal Engine. It's specific made for the artificial intelligence, and you can use the blueprint as well in the state, in the node, leaves, and all that stuff in the artificial intelligence system. I forgot to put two systems here that is kind of new system. The first thing is Meta Sound that I already use it. It was a great procedural sound creation tool that is amazing. And you can use the visual scripting to make your own sound, maybe play sound from the other stuff, and you make your own sound based on the notes and the stuff that they are already made in the Meta Sound. And other tools that I work with, it was Control Rig. Control Rig is a new system in Unreal Engine that it lets you make your own animation in editor. So with Control Rig, you don't need to work with DCC tools, digital content creation tools like Maya, 3D Max, or maybe Blender, and you can bring your skeleton mesh in Unreal Engine, make your rig. Then with sequencer tools, you can make your own animation. Maybe it's gonna be cutscene, it's gonna be gameplay animation, and everything that you want. So we can use visual scripting in most of the content creation tools in Unreal Engine. So the next things that I want to talk about is data-driven design. Through data-driven design, programmer can empower designer and artists to create and iterate with the data on games. And data-driven gameplays try to reduce a lot of works and fix a lot of issue in. Fix a lot of complexity that evolve in the game, and with data-driven system, there are a lot of games that the lifetime of the game is extended. So you need to iterate a lot of. You need to have a lot of iteration on the data and bring it to the game, and give a lot of feedback from the player, update the game again. So in this stuff, you need to work with data mostly instead of work with the asset or inside the engine. So data-driven is a kind of new approach to work with all game design data within the Unreal Engine. So the first tool that I used in game design was Microsoft Excel. Okay, so I'm thinking that game designers love a spreadsheet because with the spreadsheet you can work with a lot of data. You can simulate your stuff in a spreadsheet. Right now I'm using the Google Sheets for simulation, to put the stuff or make formula on it to bring all the data and prepare something for the game. Before Before that, it was so hard to manage stuff. So with the spreadsheet, you can script your stuff, you can make your own formula, you can calculate the data based on the previous cells, the next cells, and it's so easy to work with a lot of numbers, So the first thing that you need to work with that, you need something to put all your stuff in the game, all your data, all your number stuff in the game engine. So Unreal Engine, I already provide something for this stuff that I use some of the system that I want to show. In Unreal Engine, we are going to use three main system for data. The first thing is data table. The second is a curve table and a data asset. So the purpose of the tools is different, and let's go with data table first. So data table, as the name implies, is a table of the related data group in a meaningful and useful way. A data table is designed to work with a large amount of data and is compatible with import, export data to a spreadsheet. A spreadsheet means some extension that you can import data to other tools like CSV, like JSON, and other stuff. And the data table provide the ability to move data to a spreadsheet, document, maintain data, and then revert back to the game and update everything. Only with the export and import data. And but the things, before a designer want to work with a data table programmer or maybe other designers should make something to should make a raw container to tell the engine how to interpret the data. Okay, it's one of my my main spreadsheet that I did for our previous game. So it's consists of a lot of data, players data. Okay, is for a football game. Player name and position, the weight, height, all personal stuff. Some attributes like RPG game, like speed, focus, intelligence, all other stuff that you are going to use in the game. Okay, so it's definitely hard to work with these kind of stuff in the engine directly, because all this stuff is going to be calculated with some formula based on the previous data, and so it definitely is hard. It's hard to work with this amount of data in Unreal Engine. If you are going to work only with 1-2 players, maybe it's easier. Just you can make some simple, maybe just struct, maybe variable or array something, and work with. But when you want to work at this amount of data, so it's hard to manage in the engine. But with these tools, with the spreadsheet, you can bring your stuff in the Unreal Engine. Just make it first, then based on this title, this attribute, you should make a struct in the engine, then import the spreadsheet into engine and convert it to data table. So it's the data table version of the previous spreadsheet. Unfortunately, in data table, you couldn't edit the cells directly. So if you want to change the cell in the table, you should select the row first. In the other tool, there's a detail panel here. The other tool, you should edit data one by one. So it's a little bit hard to manage it. For me, it was so hard. So I changed all the stuff in the spreadsheet and just re-import in the Unreal Engine, so the table is going to be updated so fast. So it was one of the main tools that I found in Unreal Engine that was so useful for a game designer. And And the next thing is a curve table. Curve table is similar to data table. If you are going to work with two-dimension data, curve table is going to be your solution. And full of, for all the data that has levels in game, in game when you are going to design maybe a strategy game, an RPG game, and all type of game that you need two levels. For level of the health, level of the player level up, enemy damaging and stuff, all this stuff that need levels. So we call it two-dimension data. The first is the levels, the second is the value of each levels. Okay, so curve tables is a good solution for this kind of data. And for progression data, okay, for data progression, for player progression, for all the progression stuff, a curve table is gonna be a good feature and good solution. And definitely curve table similar to the data table, support import, export to CSV, to JSON, and you can change your stuff in spreadsheet tools and re-import to the Unreal Engine again and update your stuff. But in Unreal Engine, there is a gameplay ability system that is a great tools to make a game that all associated with ability. All the game like mostly RPG game, but you can use it in all type of games. And in this system, you are going to mostly use curve table for manipulating the attributes that related to the abilities. Here, I mentioned two curve table. The first one is in the spreadsheet, the player health and player speed. That 1, 2, 3, 4, 5 is level, and the value from 80 to 100, 450 to 550. Each level has their own value. When you want to work with this kind of data, you should use curve table. In the Unreal Engine version, you can see the exactly the same thing. But here, you can edit in data in each cells. It's not similar to data table. Data table you couldn't, but in curve table you can. Fortunately, in Unreal 5.1, you are able to change curve name as well. But in Unreal 5 and previously you couldn't. You had to export it, change something in spreadsheet and re-import it again. But in Unreal 5, fortunately they improved the tools of curve table, so you can add a curve, remove it. Previously, you couldn't remove the curve, but you can add new curve, rename it. You can add levels, remove levels, all that stuff. And in curve table, you're able to see the progression data, linear progression, the basic. But if you want to work with exactly curve data, cubic curve, there is an option in curve table. So there is curve table with cubic data. There is curve table with a linear and constant value. So here you can see the player health progression from 80 to 100, and exactly you can see the progression curve. Then you can manage it here, select the points, move it up, down, and update the table based on the stuff. So the last data management tools in Unreal Engine is data asset. Data asset is a single asset that contains a lot of data. That would be good for modularity, and if you want to make a custom data and want to work with exactly single data stuff, data asset is a good tool, like inventory system, like a character customization and stuff, that we are using it a lot in this kind of stuff. And but if you compare it with data table, if you want to change something, you should work only with single files. And imagine that you want to work with this stuff with data table, but when you change only one cell in data table or one parameter, you should save the whole data table. But with data asset, you need to only work with single asset and save it and update it. So one of the amazing tools that came in Unreal Engine 4.22, I think, it was editor utility widget that lets you make your own editor in Unreal Engine. One of my favorite tools. So, as I mentioned before, we have UMG, Unreal Motion Graphic, that you can make your user interface stuff in Unreal Engine. With editor utility widget, you can work with UMG, similar, but you can run the rest of in the editor side, not in the runtime. So when you want to change your content, edit your content, update something in the level editor, that would be cool to work with editor widget utility. And yeah, and you can set up your widget with Blueprint, CPP, and Python. I mentioned only Blueprint and Python, but you're able to work with widget utility with C++ as well. But Blueprint and Python, that would be good for designer and artists. I know that most of the tech artists that work with Unreal Engine work with Python to put a lot of stuff in Unreal Engine for data validation, for renaming, for batch renaming, batch editing stuff, and change, manipulate the material, collisions, all that stuff in the assets with utility. This one, there's a simple utility that I made for level design feedback. I made it 2 weeks ago just for to test something. And here there is a custom widget, there's a button, there's a place to put your comment. I call it feedback tool for level designer. So you need to move your camera in the scene, for example, specific this area, and at some point about the light, and at some point about this column here. So when you click on the button, move the camera here and explain that, okay, this comment is loaded this area, and click on this area, it's so easy to make these kind of tools with editor widget utility because there isn't these kind of built-in tools in Unreal Engine, but it's easy to work with. We don't need to a lot of programming knowledge, just with Blueprint and some user interface stuff, some UX knowledge. You need to make some simple tools like this. But definitely for these tools, I use data asset because I want to store this stuff, these data in the data asset. So I had to make a variable data asset to save the camera location, camera direction as well, and the comments. So the file is here is a data asset. So I connect data asset to custom editor. Here you can right click on data asset and open it, and you will see the editor here. So let's talk about the level design and blocking in Unreal Engine, specifically Unreal Engine 5. So we have 2 new tools in Unreal Engine that brought a lot of features to Unreal Engine. So you can compare it Unreal Engine 5 to Unreal Engine 4 with these features. It's totally new to me, and it was a big feature that helped us to make our level, our blackout, and maybe content modeling, a lot of things. So the first is Unreal modeling tool. So an Unreal modeling tool is a set of tools that let you designer or maybe artist to make 3D models from scratch with a lot of features. You can make basic shapes, create a lot of stuff, poly models, 3D models. You can change, edit UV. You can make LOD. You can put a lot of stuff that you could do with DCC tools, digital and content creation tools. like Blender, 3D Max, Maya. So you don't need to work with other tools right now with Unreal Engine 5 and 5.1. So Unreal already provided a lot of stuff for you, so you don't need to work with other tools. And the benefit of these tools is good for fast iteration. Imagine that you want to make a model in Blender, 3D Max, you need to worry about a little about the sizing, scaling of stuff, change it, export, import to Unreal Engine. So it's not good. Go back to the tool, change it, and re-import again. So it takes time. But with these tools, you don't need to work with other external 3D tools anymore. But in these tools, there are two great tools that is my favorite tools. I just going to mention it. The first thing is Cube Grid. Cube Grid, the polymodeling. You just drag drop your cursor on the map. You can make a grid and just make level. So easy, and it's so fast. I made a small level here, just maybe in 5 minutes. And yeah, it's one of my favorite tools in Unreal Engine 5. And finally, when you make your stuff, finally you can save all the meshes in a single mesh. Then you can apply your material on it and use it. The second favorite tools is pattern. Pattern, previously for these tools, maybe you could find something in marketplace that you should pay for it. But right now you don't need to pay for these kind of tools. You can just use a pattern tools, make a base model first, maybe I get a cube, and you can use pattern to make a linear grid, circular stuff, and there are a lot of parameters that you can change your stuff, and it would be good for level design when you want to spread some stuff on the map based on some rules. So the next feature that came in Unreal in 5 is geometry script. So what is geometry script? Geometry script is a new Unreal Engine plugin that will let you make models, 3D models, procedurally. Okay, so there are a lot of functions that you could work with Unreal, with Blueprint. Maybe I haven't tried it in CPP, but I know that you can work with Blueprint with that, and you can make your own models with a lot of functionality in these issues as well. So all the features that was in the Unreal modeling tools, you could use in geometry script, but in Blueprint. So you can call a function, change it, and make your own stuff. So that would be good to make your own tool that there isn't in modeling tools. Geometry script. So I love it. I put a lot of stuff about the geometry script in my Twitter. And yeah, you can combine geometry script with editor utility widget and asset action tools to make your own editor tools in Unreal Engine. So this is the simplest geometry script. You need to call on rebuild generated mesh, and there is some function like this append box, just make a box with 3 variable width and the weight, and you can change the value in the details panel and make your own box. So it's the simplest, but you can find a lot of complex stuff in the GitHub, in Twitter, and the YouTube stuff that people made a lot of great tools. Like I saw some procedural snow tools like that they already made something similar. So if you had a chance to take a look on Lyra project, Lyra is a great sample project in Unreal Engine 5, and that provided a lot of pre-made geometry script tools for level design. So the whole Lyra levels made with geometry script. They didn't use any 3D software for level design. So in this part, you can see a lot of tools that made for Lyra. So I use this stuff and I made my own stuff, and they made some new tools to add some more functionality to this pre-made stuff from Lyra. So it's great, you can just put your box, drag up and scale stuff, make your own mesh. So I brought the new tools that I made for our project in Gamecan is mirror tools that I made is combined with the geometry script, editor utility widget, and asset action utility. So when you are working with multiplayer game stuff, you need to mirror your map. So in Unreal Engine, you couldn't mirror your stuff directly. Yes, I know that you should put first a -1 on S scale and mirror something, but didn't work because the normal stuff definitely is broken. And so I made these tools is common with geometry script. I try to get all the stuff dynamically, try to mirror stuff based on the plane that I made here. So there was one of the great tools that I made, and because Unreal Engine 5. Okay.
Questions?
Maybe questions.
Maybe questions? No maybe questions? Maybe not questions?
Okay, thank you guys.
Okay. Okay. So, thank you very much. We have one more presentation today. And Gamecan, guys, you should decide on the food, please. It's very important. Let's make it easy. Chicken, fish, anything else? Any other meat? Meat, you just chicken, fish, chicken. I just have
So let me turn this off.
So they have time to prepare for this and managing this in the background. Okay, you send it on the Discord?
Yes.
Okay, just yeah. Uh-huh. Yeah, give it a second. It will load. It will
Eventually.
Eventually. It will Okay, good. Yes. Okay. How long to take? 30 minutes. 30 minutes. Okay. Okay. So the next presentation it's around half an hour, and then free time. Free time. Okay. So tell us about you a bit, and let's start.
Okay, hello friends. I'm Leo. I'm currently acting a developer at Gamecan, and today we're going to talk about how do we use artificial intelligence in our engine, how do we use the framework to make our agents, that's how we call AI in the games, more smart and more interesting. So, about me, I have a little bit over of 5 years of programming knowledge. I've worked with operational systems. I was developer also for web and also embedded systems, so making Internet of Things. I made my own drivers, bootloaders, played around with everything in Linux. And well, at some moment I changed to game development. And well, Adi said that before he had darker hair and actually had some hair before. So this is me after game development. So I've worked on first the Overtap, which is the main part we made at Gamecan. It's a multiplayer third-person shooter with parkour, really cool. I also worked on Fault Elder Warp as a freelancer. I worked for 8 months there. It's one of the games that is based on Paragon. If anyone played Paragon before, and recently shut down. But I also worked on Maximum Football 2023, which is a team-based sports game. It's an American football game. And I mainly worked on artificial intelligence and also worked with a lot of multiplayer and character movements, system and tools, anything that could be done I was about there doing. So, I want to start with a quick story. How many of you here play Elden Ring? Okay, we know it's the game of the year. No doubts about it. But yes, when you first start Elden Ring, you see how difficult the game is. But what was the most interesting thing for me in the first few hours of gameplay is Margit, the first boss. And is that one that when you die, he said, "Take your foolish ambition to wrath." And every time you die for him, you hear the same phrase over and over again. It gets your mind. But the cool thing of Margit for me is that it's extremely engaging and it's kind of predictable sometimes because let's say you are there, you decide, okay, it's time to drink a potion. The moment you start drinking a potion, Margit just throws a dagger at you even though he's far away. So he's there somewhat reading you, but he doesn't do this every time. So it has some randomness in the background, so he knows exactly when to throw the dagger. He knows exactly when to switch from you to someone or whoever is playing with you if you're playing multiplayer version. So it's actually engaging and it doesn't get to the point where it's annoying because making hard AI is pretty simple. Like, for example, in a shooter, just make the AI 100% accuracy, you're going to kill all the time. But this is not actually fun. So what are we going to see in this presentation? We're going to understand the difference between game AI and machine learning. And we're also going to understand the basics of making vanilla AI in our engine with the tools they already provide. And we're also going to see how do we expand this framework for more complex behaviors. And I'm going to tell you that, for example, Margits wouldn't be easy to make with the default tools. And how we get there, how do we make our own Margit in a real, for example. So these methods I'm going to talk about, they were battle tested, already explored in big conferences like GDC and AI Summit. So it's not novelty, but I would say somewhat novelty exploring every engine. So the first topic is game AI versus machine learning. Nowadays, the moment we say AI, what comes to our mind is like Midjourney. We see image generated, we see deep learning machines learning how to play chess, how to play Go. And actually, game AI doesn't mean that. But it can be used. So they've been using machine learning for some things like the Forza Drive avatars. If anyone plays Forza before, they had this feature called Drive Avatar in Forza 4, where you could have the AI driving and simulating your behavior. They also made AI for Dota 2, so OpenAI, they have the huge cluster playing like professional players, and they even ended up having the AI beating up the world professional, the best players in the world. And we also had some old things like DeepMind, Deep Blue, the one that played chess, and AlphaGo. But okay, this is not game AI, it can be used. We also have some recent researches on how to implement procedural animations with AI, which is really cool. But this is still on the research field, it's kind of blurry what we're going to do with that. But what is actually game AI? Game AI means things like state machines, which use in majority of games, we're going to see examples, or behavior trees that have been heavily explored in the past decade with games from Square Enix, Control, Batman series, obviously made in Unreal, Halo, Crysis. We also have some other models of making AI, like goal-oriented action planning for the Fear series, Fallout. We also had the same system in Middle-earth, Shadow of Mordor, and the most recent Tomb Raider games. And we also had many other models, many other ways of creating AI. So this is a really simple example of a state machine for people who never saw one state machine. So it's basically a block of states. So you have a state like evading, and then you have the transitions to other states. And the transition is basically a rule that defines how do you go from this state to the other one. You know that you only attack if you are actually in your sight and the player is near you, so that's the moment you can attack. So this is a state machine. We've been heavily using this thing, but they have some problems, and we're going to talk about them. So the alternative that we have in a real engine, we started in a real engine 4, is a behavior tree. The behavior tree is like a tree upside down. So we start with a root over there in the top, and it grows down to branches and finally to the leaves here, what we call the tasks. And it's actually much more simple to understand from this graphic than to understand something like this. And this is the main reason why they made this system in a real engine. So before I get into there, we're gonna talk a little bit before of the game framework because I'm gonna use a lot of technical jargon here. So I'm explaining the concepts first, and then we're gonna get there, the real things. So the first concept is an actor. An actor is any object that can be placed in the world. The second concept is a pawn. A pawn is an actor that can be possessed by a controller, and this is the actual physical representation of the agents. And the third concept is a controller. The controller is something responsible to possess the pawn and get control rates, and it could be either a player controller or an AI controller. So, how do we use the AI architecture? How are we supposed to behave? Paulo Souza, a fellow evangelist of Epic Games, he defines the Unreal architecture as a body-soul-brain pattern, where body is the visual representation of the character, that means the pawn. We have the soul being the entity that controls that movement, is the controller. We have the brain, which defines the behavior, this is where I use the behavior tree. And we have the memory, that's where it stores the information is to behave the blackboard. There's so much to talk about each one of those parts, but we're actually going to focus today in the behavior trees. So this is a visual representation on how the flow goes. The upper part we have there the leaves, there are the tasks. There are things that AI can do like attack or do the motion. And then from this information we can access the memory there on the blackboards. You can see the icon is literally like a blackboard because it's the place where you draw and store information. We have the brain here with the behavior trees. We have the soul, which is the controller, and the body, which is the pawn itself. And on the other hand, we have a comparison here with the players. So the input starts from the controller, whereas the brain, so it's you playing, that goes from the controller and then ends up in the pawn. So, what are the main differences between state machines and behavior trees? The first thing is that behavior trees are event-driven. So they don't even need to tick all the time. They avoid doing necessary work every single frame. And they don't need to check if any change occurred at all. What they do is that they passively listen for events that can be used to trigger changes in the tree and go from one place to another one. This grants lots of improvements on performance and debugging, but there's also the drawback that requires some structuring to understand how to take advantage of the architecture. So it's just not about going there and spinning nodes and organizing. It's kind of hard to manage if we don't understand what we do. And we use this word event-driven, another technical jargon, but it's just a way of saying, instead of constantly asking, are we there yet? We can just rest until we are prodded and full and told we are there. That's the moment we actually make some change according to the behavior. So, what is actually a behavior tree? What is the formal definition of it? Behavior tree is a model of plan execution that describes switching between a finite set of tasks. So it allows for complex agent behavior. It's easier to understand the code and state machines. It's easier to debug, and it's widely used across the industry. It has been recently heavily adopted by all the engines outside from Unreal as well. So the formal definitions Wikipedia says is a data structure with a set of connected nodes. Each node in a tree can be connected to many other children with some restrictions depending on the type of the nodes, but it must be connected to exactly one parent, except for the root node, which has no parents, and the root's where the things start. And how the execution flow goes. As I stated before, the tree starts execution on the roots, and it goes down here to the branches and ends up in the leaves, which are the tasks. And the execution goes from top to bottom, and from left to right. And even in Unreal, the nodes here, they are casually and purposefully annotated with this number here, which indicates the order in which it will be executed. So, what is a node? A node is a structure, data structure, that contains data and connections to other nodes called links. There are four main different types of nodes. So we have the composites, the decorators, services, and tasks. Composites, they define the root of a branch and the base rules for how the branch is executed. And they are basically used for flow control. So if the tasks, they do stuff, the composites define where and how those things should be done. So we have three main types of composites. We have sequence, selector, and simple parallel. The tasks, they are the leaves of the behavior tree as I stated before. and they doing things, executing given tasks like moving, making noise, or activating an ability. They can have decorators or services attached to them, and later we're going to see exactly what are those services and decorators. But we have two clear examples here on move to or play a sound, for example. So the first composite node we're seeing is the sequence. So the sequence executes children from left to right, and stops the execution if any child fails, hence the sequence fails. If all the sequence children succeed, then the sequence succeeds. And this is extremely useful for when it's necessary to execute the list of tasks in order, but it needs the entire branch to be cancelled if the tasks fail. So on the left we have an example where the sequence succeeds, and on the right we have an example where this task here is failed on purpose because it's a node that should take 1 second, but we're going to fail after a time limit of 0.1. I don't know if it's readable here, but it's a time limit of 0.1. So we're purposefully failing this thing. And when it happens, the sequence fails, and it restarts the tree. It goes to the parent node. We also have the selectors, which executes the children from left to right, and they stop executing when the children succeeds. Hence, the selector succeeds. If all the selector's children fail, the selector fails. And this is useful for making decisions to execute a task or a branch based on a certain conditions, for example, a set of parameters. So the selector looks more like the if-else statement. If this happens, then execute it, otherwise go to the next one and see what's going on there. And on the left we have one always executing, so it's always succeeding, just keeps executing. And on the right we have one that fails on the first and executes the second one. I guess the graphical thing is pretty easy to understand. The third composite is simple parallel. A simple parallel allows a single task node to execute alongside of a full tree with one or more nodes. And this is useful for executing activities in parallel. For example, we could have a main task with shooting, and on the background we could be strafing, for example, in shooting games. And it has two finish modes. We have the immediate. That means that when the main task finishes, the secondary task finishes immediately. And we also have the delay. That's when the main task finishes, you just wait a little bit until the secondary finally finishes. And on the left we have a case of immediate. So when the first one finishes, the second one finishes immediately and it just restarts. And the other case is delayed, so it finishes the first one, the main task on the left. And then on the right here, it waits for the secondary to finish before actually restarting. And I would say this is the most interesting thing here now, is the decorators. So the decorators, they work basically like gates, and they define whether a node on a branch or a tree, or even a single node can be executed or not. Say they are also known as conditionals in other behavior tree systems. And in computer science in general, we're going to have some names for some things, and other systems they're going to call it another way. So yeah, in the other systems they are called conditions, in the real they're called decorators. Conditions decorators make the behavior tree more intuitive and easier to read, so it's almost like if statements in traditional programming languages. Decorators are often used alongside with selectors, so if a condition fails, just go to the next one, and then it interrupts the execution flow of lower priority nodes if you set for that. And we're going to see what that happens. So here we have two examples of decorators. So if you can see the targets, you actually do something. In this other case, you're basically checking anything, because you can also do decorators in blueprints, so it's easier to iterate as well. The next node we're going to see are the services. Services, they execute in defined sequence as long as their branch is being executed. They are designed to perform background tasks that update AI's knowledge, often making checks and writing information to the blackboard. So it's a thing running in the background that eventually goes there and writes to memory the information. And these take place of traditional parallel nodes in our behavior tree systems. So here on the left we have two examples. One is the default focus, and this focus is basically where your AI would be looking at. And the second one is running EQS queries. And EQS is another C scenario. We could be like a whole day talking just about it, but it's basically to gather information about the environment, and it's also super easy to use. But there are some problems with behavior trees as well. behavior trees can get huge and hard to manage. So pruning and designing these trees requires lots of creative thinking. Complex behavior many times are hard to modify and extend, and everything comes down to if-then statement, so it's basically binary. So when you have a huge behavior tree and you need to change something, you go there and it feels just like doing arborist work in a bonsai. You have to be extremely careful of pulling the branches there, cutting carefully so you don't break everything. And even if you do everything right, sometimes you may go in our behavior there, you change a little bit thing, and then your agent just stops working totally. It becomes like just broken, and then the guys are gonna say, hey, the build's broken here, what happened? No, we just changed this small detail there. So it's actually really complicated. And well, how do we solve that? I'm gonna drink some water first. How do we solve this limitation of behavior trees? And well, we don't want to give up on them because they are already there in the engine and we like to use them, they're beautiful, they're easy to start. And we don't want to also go back to state machines. We don't want to have those other models. How do we make this better? So, there's a concept called utility theory. And, well, if the harsh transition for yes to no doesn't always model reality, we know the world's not black and white, we have something else. Utility theory has its roots in areas such as psychology, economy, sociology, and classical game theory as well. So they got this idea from other fields and they started implementing in game development. So what's the idea behind utility? It's actually extremely simple. It states that every possible action is scored at once and one of the top scoring actions is chosen. And we have this reference here because we're gonna later talk about the who started this cool thing. And applying to utility theory with algorithm techniques, they lead to more interesting AI, so I highly believe, it's not written anywhere, but that targets and most Elden Ring bosses, they probably use somehow something similar to utility in some extent. And we have some tools to use together with it, for example, response curves. We have population distributions and weighted randoms, and today we're going to mainly focus on response curves because it's the most simple to understand. So, there's a guy called Dave Mark, which is I would say the most famous AI developer in the whole world right now. And he developed something called infinity axis utility system that consists of a few pillars. The first one is an action, which is like a task in our behavior trees. And we have considerations, which we call axes, that describe why would we do this action. We try to rationalize the idea behind doing something. And an axis could have input and parameters. And why do we call infinity? Because from an action, you can actually have an infinity set of axes you can keep adding, and you can keep modeling your behavior even more to the point that could be even real. And those actions and those axes, they are scored over time, and they are scored depending on the target. So you could have, for example, some actions that only execute on yours, some actions that execute on friendly or enemy. So you can have those types of attitude towards an affiliation. And what is the cool thing about this is that when you want to execute a behavior, what it does is that we have a core selector that he goes through all those actions and through all these agents that you can actually perceive right now, and then he scores those considerations one by one, and then he multiplies all those values together, and then he comes up with something between 0 and 1, normalized. And this value is what we call utility. So let's say we have a couple actions there. We see which one has the higher utility, which one makes more sense to do right now, and that's the chosen one. And additionally, not only having the value, but we can also modulate those axes to what we call response curves. So we have different types of response curves, like linear, quadratic curves, logistic, and logit. And we have some examples here of action and axis. So, use health potion. Why would we use a health potion? We could check if my health is below a certain threshold, for example. Attack somebody. Why would I choose to attack somebody? How far is that enemy away from me? What is my health right now? Is it reasonable to go there if my health is low? And what is my ammo? What if I have like only 2 bullets in my magazine? Is it worth to try to attack this enemy and alerting me that I'm here? We also have another example of move to cover, that we could have many different considerations like, okay, am I actually being threatened right now? Or how low is my health? Do I need to take cover? How low is my ammo? Or how far is the cover away from me? How good is this cover? Like, is the cover going to protect me from all the directions? How do we investigate those things? So these are examples on things you could rationalize to understand an action. So we have a few examples of response curves here, and I know that every time we put up those things in the screens, you guys get a little bit terrified looking those axes and those values on those curves. It is a bit terrifying at first, but in the end it's just data. It's just a bunch of pairs of number and value, so you can just understand that they are there and they do something. So, what is the problems with vanilla utility-based systems like the one they had in, how's the game called? Yeah, Guild Wars. And I think they started this thing of utility system in Guild Wars, and they basically had a data-driven system where you could modify an XML, and then from this XML you could have the decision-making. And well, this is kind of agonizing and it's hard to iterate for designers and scripters, and these are the main guys that we want to actually go there and translate their minds and their ideas into the AI. And accessibility and scalability of behavior trees is way bad. We already saw how good they are, how good they look. But how do we solve the problems? So people started, okay, how do I build utility in a real engine? So Tom Luman, which is another big guy in Unreal, anyone that works in Unreal probably has seen either read or watched one of his tutorials on YouTube. He's huge. And he also made an interesting implementation of utility in Unreal. But unfortunately, it doesn't make use of behavior trees. But this guy called Bill Mario, which is one of the AIs for EA games, if I'm not wrong, he proposed a few simple components to integrate utility into behavior trees. So, utility selectors, actions, and axes resemble behavior tree components in some way. We know that we already have selectors, we already have actions, which are our tasks in the behavior trees, and we already have axes, considerations. They do resemble some sort of the decorators. So, how does it become possible? We have an attempt to fix the behavior tree architecture's biggest weakness without sacrificing the strengths. And Unreal Engine makes that possible with the open-close principle. So it's fairly easy to just extend what's already there in the behavior trees. And our starting point was at Gamecan was looking into this Project Borealis, and this is a fan-made Half-Life 3 episode they've been making for a few years now. And they actually made a version of utility AI into a random engine incorporating the behavior trees. So we use that as inspiration for what we have now. And we're going to talk about what we expanded there and what's cool in this plugin. So this is an example of a tree you build using this plugin. We have a root node here. We have, actually this point is a user selector, but here we have our utility selector. So for each one of those branches, we have what they represent. So retreat or move to cover, or this one that's not named but is actually strafing and shooting, and be more evasive here or throw a grenade. And we have all of this data planified, and everything depends on how do you consider it, how do you rationalize why and how to take that action. And this becomes super simple because it's just a matter of setting up everything here in this huge list, and then you can start tweaking what each one of those considerations and see how well you can model that decision. And this is how the actions and the axes look. We have a behavior here, we have a service attached here as well, then we have the considerations. And for each behavior here, we can see, okay, do you want to target hostile, target neutral, friendly yourself? You can choose what type of affiliation you want to go through and before actually evaluating the utility score. And we also have the initial weight here, which is a way of limiting the highest score you can get. I actually talked about, okay, utility is a number, okay, but what is that actually? So utility is a number between 0 and 1. Why? Because it's easier to manipulate. And the idea is that, for example, distance. How do we put distance between you and someone between 0 and 1? That's actually a harsh problem of normalization. But you can do some math there. You can define a maximum distance that you consider valid. Then if you do maximum distance minus minimal distance divided by the maximum distance, you actually get a number between 0 and 1, and that's finally our axis. And we also have a really cool curve editor, because as I stated before, after doing all of your reasoning, we also want to modulate this reasoning through curves. Why? Because the problem is about choosing, and it's about how can we make this closer to real world. In the real world, things are described by curves. They are described by math. So for example, you could use a polynomial curve, and then you can just change the parameters in here and say, okay, I want my utility to depend on this curve. So if I get a value of, I don't know, 0.5 of utility, for me, this actually means a really high number. So from 0.5, it will be converted to this other value here, which could be around 0.8 or 0.9. So you can use curves to modulate. And this was actually built in Unreal Engine 4, but now in Unreal Engine 5, we have the runtime curves, and we have a special editor there, which would be looking a little bit better. And this is one of the extensions we made in our version, which is integrating the utility with the gameplay debugger we have in Unreal. If anyone used AI before in Unreal, you know that you have the gameplay debugger where you can enable the perception. You can see how the AI is seeing, who is seeing last time, and then you can actually extend this module by having more categories in the gameplay debugger. And one of those things we did was this debug for our considerations. So for example, this character here, he has two behaviors. He has the behavior of returning the flag and the behavior of going for the flag. And it actually has only one axis. And this is actually a really dumb example, but just to show how the tool works. So in this case, the consideration, which CON stands for consideration, is target has flag. If it has flag, value 1, doesn't have flag, value 0. And in this case here, we see that this behavior of going for a flag stated and 1 was selected as the best behavior because it had the highest score. And that's mostly it. I want to, before opening for questions, I want to make some acknowledgements here. So the first thing I want to thank is my colleagues Ali and Andre, which are here, and they basically helped me discover the secrets of AI in Unreal Engine and going through the source code and unveiling everything in there. And Martin and Flavio for trusting me, and my family for making me who I am. Thank you.
Any questions to this beautiful person? There is one.
How well does it scale with the number of agents?
Yes. How well does it scale with number of agents? The thing is that you have to think carefully of your considerations. For example, if you know that an agent needs to be doing a line trace all the time and every single tick is problematic. So it does scale depending on how well you craft your considerations. If your considerations are actually heavy, then the utility is going to be heavy. But the same problems often happens with other systems at all because you have to do those checks anyways. So you just have to be somewhat careful with what you do. Any other questions? Okay, thank you.
Thank you very much. Okay, well. Unexpectedly, our official part was much, much longer than I would even anticipate.